my ninja warriors, we are here to revise the complete chapter Binomial Theorem with the help of mind maps in a fast track manner. Along with that, I'll be letting you know that which all formulas or concepts are frequently asked or most repeated ones in your JEE examination. Okay, so without wasting any time, let's quickly start. And also on top of that, within 2 slides, we are going to cover the complete chapter. Only just 2 slides or 2 pages. Okay. So over here, we are having the very first thing, which is your binomial theorem. Okay. So for a natural number, your binomial theorem expansion looks like this: a plus b raised to power n is a natural number. So over here, we are having NC0, then NC1, NC2 and all the way up to NCN. So generally we call it NCR. NCR is binomial coefficient. It starts with NC0, then NC1, NC2 and all the way up to NCN. One more thing you have to notice, that if I talk about power of A starts with N and it keeps on decreasing by 1 and eventually it becomes in the last term 0. But with B, a different thing is happening. It starts with the 0, b power 0, b power 1 and eventually becomes n. Also, one very interesting thing to notice over here is every term, the combined power of a and b is n plus 0, n minus 1 plus 1, n minus 2 plus 2 and so on, and last is n plus 0. Okay, and one more thing, okay, that total number of terms, if I just count, it is going to be not n, but n plus 1 terms will be here. From 0, 1, 2, 3 and all the way up to n, there will be how many terms? N plus 1 terms will be there. Okay. So the total number of terms will be n plus 1, which is written right here. And this is your general term. What is a general term? So if you understand, the first term is having NC0, second term is having NC1, third term having NC2. So R plus 1th term is going to give you NCR, A raised to power n minus R, B raised to power R. Understand, this index NCR is matching with power of B. In every term, NC2 B square, NCN B power n, NC1 B power 1, just like this. And this is the sigma notation of that particular series. Okay. So this is how your binomial expansion looks like. Okay. Now that you already know that these are your binomial coefficient NC0, NC1, NC2 and all the way up to NCN, why not just talk about properties of it, properties of binomial coefficient? By the way, in this, the questions from binomial theorem are most asked from the general formula, general term formula. This is a general term formula. So this is highly frequently asked topic. They can ask you terms independent of x. They can ask you coefficient of x raised to power 13 and everything like that. So I have taken a session. You all know. You can just go and watch it. Okay. All right. Now we will talk about properties of binomial theorem one by one. Okay. So properties of binomial coefficient one by one. So understand, first of all, NCR. This is your binomial coefficient whose expansion is n factorial upon n minus r factorial, okay? So this is your NCR. Now based on this, we are going to understand properties. Okay. The very first property is NCR is equals to NCN minus r. Now what is this? Understand. Suppose 6C2 is given. So 6C2 is equals to 6C, 6 minus 2, which is 4. So this is that property. Okay, this is what it means. And the very next property which you are seeing is exactly the same, just the way of writing is different. So suppose if somebody tell you that NCR is equals to NC6. So what will you do? Obviously, ma'am, R and 6 are equal. But wait, R and 6 are equal, but don't you think you are missing out on something? So in here, if this situation arises, obviously you will write R is equals to 6, but you will also write that R plus 6 should be equals to your N. Over here, can you see 6C2, 6C4, basically 2 and 4 sums up to 6. This is that property. So NCR and NCS, if they are equal, then R equals to X is one thing, but R plus S should be equal to N. This should also be in your answer. Okay. Next property. Okay, so I will call these two as a single property. This is single property. Next property to that is NCR plus NCR minus 1 is equals to N plus 1 CR. Now, the moment you will look at this property, you'll be like, ma'am, how to revise it? But I have a trick for you. Understand what is this property, what is this left hand side wants to say. So if you have 6C3 plus 6C4, basically the upper index should be same, 6, 6. But the lower index should have a gap of 1. Then your answer will be, your property says that just increase 1 to this upper index, that is 7. See, and now out of 3 and 4, tell me which one is bigger. 3 and 4, 4 is bigger, so 7C4. Now understand this property. NCR, NCR minus 1, N same. So just increase 1, N plus 1. And R minus 1, which one is bigger? R is bigger. So this is also one of the properties. And now this property. Very important property. So many questions are from this property. And this property says that NCR upon NCR minus 1. See, now these two terms were in summation. But now these two terms are in division. Wherein upper is bigger, upper index is bigger, and lower index is smaller. So there is a gap of 1 again. So how to understand, how to write? Just there is a trick again, ninja trick, okay? So 6C5 suppose upon 6C4. Can you see upper index? 6, 6 should be same. 5 and 4 there should be a gap of 1. Then how to write the final answer? Now understand, you should be writing 6 minus 4. This 6 minus 4 is the trick. 6 minus 4 upon, this is going to give you, now 5 you should write over here. So this should be your answer. This is your 2 by 5. Same thing, let me just tell you. N minus R minus 1. N minus R minus 1. Can you see this N minus R minus 1? Yes. And this R should be written directly in the denominator. This is how you should write, okay? And this is the most underrated property, very underrated property, which is NCR is equals to N by R. So can you see, this is N, this is R. So N will come in front in numerator, R will come in front in denominator. So suppose 6C3. So this is going to become 6 by 3. Okay. And now you just have to reduce 1 index from upper and lower both index. 6C3 will become what? 5C2. That's it. So this is how it is. NCR, N by R, multiply now N minus R, N minus 1, R minus 1. So these are the properties, and trust me, out of each and every property is important. All the properties are NTA's favorite. Okay. Alright. I guess that this is done now. And let us move towards the next thing. Now coming back to your binomial expansion. Okay. So sometimes one question is of the type wherein they tell you that, okay, calculate the third term in the binomial expansion. So for that, obviously, you have to put R is equals to 2, right? Then only you will get third term. But sometimes what they tell you is, what is the third term from the end? Now, third term from the end is which term from the beginning? That we should know. So now, kth term from the end. Suppose third term is asked, or fifth term. Usually they give fifth term. Fifth term is most popular. Okay, I think you should remember it. Fifth term from the end. Fifth term from the end. From end is equals to what? N minus k plus 2. So, fifth term from the end is n minus 5 plus 2 from beginning. Okay, from beginning. So, this is going to become n minus 3 term from the beginning. Okay, so if you know this, now term from the beginning, you can directly use this formula. Once you know the term from the beginning, then so you can use this formula. Okay, all right, clear? All right. Now, we are having middle term. Okay, so whenever you will have a series, obviously you will have middle term. And one more thing, whenever you have total number of terms odd. Total number of terms odd. That means there are going to be one middle term. I'll tell you. Total terms are 3. Total terms are 3. So there will be one middle term. Total terms are 4. There will be two middle terms. So when total terms are odd, you are going to get one middle term. Now understand. If n is even, this is even, n, power n, a plus b power 4, how many terms will be there? N plus 1 terms. Odd number of terms will be there. So there will be single middle term. And the formula is just, if it is even, n is even, just divide by 2 and add 1 to it. You are going to get the only middle term. Okay. But ma'am, if n is odd, so n plus 1 will become even. And whenever you have total number of terms even, you will have two middle terms, right? So over here, n plus 1 by 2. So if n is odd, just add 1 to it and divide by 2. Whatever you will get, the very next term will be the one more term. These two will be the middle term. Two middle terms, okay? So this is the middle term. Again, middle term is not the most frequently asked question. But yes, you should at least remember the formula or the technique that what they are asking. Okay, all right. Now, let us move on to the next thing, which is this. Okay, so now you know the binomial expansion of a plus b power n. You should always know what should be the binomial expansion of a minus b power n. If at all minus sign occurs over here, you just have to replace b by minus b. So over here, b power minus 1 will be replaced by minus b. And this b square, if at all I replace b by minus b, it will not get affected. So all the odd things will get affected. NC1, then NC3 will get affected. So just like this, if you can see, right? So here a plus b raised to power n, so you already know. A minus b raised to power n, replace b by minus b. So what you're going to get is, this index will become negative minus NC1 plus NC2, but so alternate plus minus sign will be there. Okay. Alright. So this is okay, fine. But now, if you add these two terms, these two equations rather, I would say, if you add these two equations, a plus b power n plus a minus b power n, you will realize that these two terms, NC0, will get added. So it will become 2NC0, a power n, b power 0. Okay. If I add these two will get cancelled out. Okay. So NC0 becoming 2, NC1 is gone, cancelling out. NC2 is again becoming 2. So all the even indexes will exist and become twice. All the odd indexes will be gone. Okay. So you will get a plus b power n plus a minus b power n. That is going to be equal to twice of NC0 terms, then twice of NC2 terms, and twice of NC4 terms, and so on. Okay. Now similarly, this question, you might get this type of question. There has been some questions on this pattern wherein they are asking about a plus b power n plus a minus b power n, or they can also ask you about this, which is subtraction of these two quantity. Now the moment you subtract these two equations, this will get cancelled out, this will get added 1. So NC0 is cancelled this time, but NC1 becoming twice, NC3 term becoming twice. So NC1, NC3, NC5 and so on. Okay, all right. So page number 1, slide number 1, crystal clear to you, I guess. And now let us move on to the special case of binomial theorem, which is this: 1 plus x raised to power n. You should pay special attention to this form. Very, very popular and frequently asked questions are from this form, which is again, now your a is gone. See, a is gone. NC0, x raised to power 0. Basically, a is 1 and b is x. So remember I told you that power of b and index NCR are this NC0 and power of b will follow each other, will be same. See, NC1 x raised to power 1, okay? NC1 x raised to power 1. Okay, this is your 1. NC2 x raised to power 2. Can you see index and power are matching, and so on. Again, n plus 1 terms are there, but what you have to remember it is coefficient of x raised to power r is NCR. If somebody asks you what is the coefficient of x raised to power 7 in the expansion of 1 plus x raised to power n, you will be like NC7. Whatever the power of x will be, your index will match, lower index will match with it. Okay, this can be written down in the sigma summation form as well. And now here comes the very important formula, most important formula, which is you are going to get if you put x equals to 1 in this. Just both side in this expansion, you have to put x equals to 1. On the left hand side, 1 plus 1, 2 power n. Can you see 2 power n on the right hand side? Yes. And on this side, put x equal to 1. The moment you put x equals to 1, NC0 plus NC1 plus NC2 and all the way. So this is nothing is written. That means n is there. NC0 plus NC1 plus NC2 and all the way up to NCn is equals to 2 raised to power n. Okay, clear? Right? Next. So first you have put x equals to 1. Now you have to put x equals to minus 1. The moment you put x equals to minus 1, your left hand side becomes 0. So can you see this 0? And here if you put x equals to minus 1, what will happen? NC0 as it is, x equals to minus 1. Minus n, this minus sign will come out. Then x square minus 1 square plus sign will be there. But next alternate plus minus sign. NC0 minus NC1 plus NC2 and all the way up to this is going to get 0. These two summation series of combination coefficient you have to remember. Very important. Now, I am going to get 2 more equations with the help of these 2 equations. Ma'am, how? You know it, right? So, I will add them and I'll subtract them. Very easy, okay? So, first add these 2 quantities. If you add first and second, you will realize that C0 is adding up. But C1 and C1 is getting subtracted. So, that means what I'm going to get is NC0 plus NC2 plus NC4 and all the way up to all the even indexes. Okay. So, if I just make you understand, if you add these 2, what will you get? 2 NC0 plus C2 plus C4, all the even indexes, and this is on the right hand side also you are adding 2 raised to power n plus 0. Now this 2, if you just remove it from here, just put it over here, 2 power 1. So your final answer of this even indexes, sum of even indexes will be 2 power n minus 1. Can you see this third formula? And same, if you subtract these 2 quantities, so first minus second, C0 gone, C1 will add up. So twice of C1, twice of C3, now odd indexes you are getting, right? So this is going to give you again same result. Same result will be there because same procedure is there. You have to subtract 2 power n minus 0 upon 2 raised to power n minus 1. That means sum of even indexes and sum of odd indexes both are equal. The right hand side is equal. Okay. All right. Clear? All right. Now, some more series based formulas you have to keep in mind. This is something which is your arithmetic progression combined with binomial coefficient. Let me show you. So, suppose over here, this is NC1. So, this is actually 1 multiply NC1. And if you just go back and write one more previous term, it is 0 multiply NC0 plus 1 multiply NC1 plus 2 multiply NC2, right? 3 multiply NC3 and all the way up to n multiply NCn is equals to n, same, 2 raised to power n minus 1. This is the formula you have to keep in mind. Direct result Sometimes direct question they will give you. Direct, they will just introduce, suppose n is 30, n is 50. Direct result you can apply free 4 marks straight in your pocket in JEE main just because of this revision, right? Okay. Another thing, now understand. This is something which I'm going to call as product of, summation of sum of product of binomial coefficient, BC, binomial coefficient. What is this, ma'am? Please make us understand. So here can you see that two binomial coefficients are getting multiplied. The moment you see two binomial coefficients are multiplied, always think about adding the upper index and lower index. Okay, let us add upper index. What is happening with upper index? Ma'am, n. So upper index, sum of upper index is, ma'am, n plus n, 2n. What about sum of lower index? Ma'am, sum of lower index is r plus 0, r. Sum of lower index is 1 and r plus 1, r plus 2, r plus 4. Ma'am, different, completely different. No, not happening. Not understand what I'm trying to say. Don't do this. You have to change one variable. NC0, if I just keep NC0 as it is, NCR will become NCn minus r. The second coefficient I'm going to change throughout the series, plus NC1, NC n minus r minus 1, correct? NC2, NC n minus r minus 2 and so on, correct? Okay, so this is going to give you what? N plus n, 2n c, right? And now just tell me again, sum of lower index, ma'am, 0 plus n minus r, n minus r. Ma'am, this and this, n minus r again. Sum of 2 and n minus r minus 2, ma'am, n minus r again. And last also, nc n minus r, the second index will become what? nc n minus n, 0. So nc 0. Can you see again the lower index sum? I can see straight always n minus r. So your answer will be sum of upper index, which is constant, 2, and sum of lower index is again n minus r. This is your answer. Very, very important. Very important. This one is very important. I mean this one. This one is very important. So understand, you have to convert the other combination using the property NCR, NC, n minus r, and then just think that every product should give you the same sum of lower index. Okay. Alright, this is again the property. Now this property, again the similar property, although you are not able to see it, but I will make you see it. Okay. C0 square is actually product of NC0, NC0, NC1, NC1, NC2, NC2, correct? NCN, NCN. This time sum of upper index is 2n, correct, ma'am? But sum of lower index again not. This is 0, then 2, then 4, not working out. Okay. So what you have to do is this NC0 is going to become NCN. Remember the property, the second index you have to change. NC1 as it is, NCn minus 1. NC2 as it is, NCn minus 2. Now tell me, the sum of lower index is always 0 plus n, 1 plus n minus 1, n again. This plus this, n again, right? So yes, now just tell me, sum of upper 2n, c, sum of lower n. 2ncn will be the answer, right? 2ncn will be the answer. Okay, all right, okie dokie. So just remember this, c square, nc1 square, nc0 square plus nc1 square plus nc2 square and all the way up to ncn square is 2ncn. Again, another thing over here. And now the last thing, which is your multinomial theorem. Ma'am, what is a multinomial theorem? Multinomial theorem happens when there are more than two terms. Suppose x plus y plus z, x plus y plus z plus w power n. Okay. So now to understand multinomial theorem, we have to take the inspiration from binomial only. Just tell me, a plus b power n. Tell me, a plus b power n will be sigma r equals to 0 to n. Correct? Am I writing it correct? Now just tell me. NCR. Rather than writing NCR, can I write n factorial upon n minus r factorial and r factorial? And here a power n minus r and b power r. Now understand the binomial theorem, then just rewrite multinomial theorem, okay? Understand, n factorial, that means power factorial is here, okay? So power factorial should lie over here. So here also, if x1 plus x2 and all the way up to xr power n, so n factorial should be here, correct? Okay. Now because it is a binomial, there will be two terms, like two things involved, a raised to power something and b raised to power something. So here a raised to power n minus r, b raised to power r, correct? And the power, whichever power you are seeing over here, all the factorials will be there. And also the sum of all the powers is equals to n minus r and r. If you add, you're going to get n. Now take the inspiration from this and understand this. See, this is n factorial. Now there are how many terms? See, there were two terms, binomial. Here there are r terms. So we'll write x1, x2, x3, x1, x2, x3 all the way up to xr. There will be different powers, k1, k2, k3, and factorials will be writing down in the denominator. Just like this. Powers in denominator. Every power will be in denominator and sum of all the powers is equals to n. Right? K1 plus K2 and all the way up to Kr is n. So this is how your multinomial theorem is. So if someone says x plus y plus z power n, can you just write it down? Or can you just, yeah, n. So it is going to become x, okay. It is going to become what? N factorial upon, now, x power a, y power b, z power c, here a factorial, b factorial, c factorial, and a plus b plus c is equals to n. Sigma is already there, right? So three terms mein, this is how you have to write the multinomial theorem, okay? Now multinomial theorem is done. Now number of terms based on multinomial theorem, you all should know. Number of distinct terms, how many, like if you open the sigma, just like binomial theorem, very simple, n plus 1 terms. But if you open this sigma, how many distinct terms you will see? So there is a direct formula at n plus r minus 1 cr minus 1, and this formula is exactly same as Beggar's method, where n is this power and r is number of terms involved over here. So here with this we are done with complete binomial theorem, and now if you will see, you will realize that the complete binomial theorem is limited to, is residing in two slides. You can call them mind maps also. So the very first page is this. You can see, yes, your binomial expansion, number of terms, very important, general term formula, all the important properties of your binomial coefficients. Then your middle term is right here, and apart from that, if you add two binomial expansions and if you subtract two binomial expansions, what are you going to get? You are going to get like even index terms, twice of even index terms, here twice of odd index terms, okay? And next, special binomial theorem, very important. So many questions asked in previous years from this. These are the four properties that you have to remember. Then three more property. One is AP plus binomial. The second one is sum of upper index 2n. Sum of lower index should be constant. It should be n minus, it is right here, n minus r. Same with this 2ncn, and this is your multinomial theorem. Now if you look for these mind maps, the last two slides, the complete slides, I'll be attaching the PDF in the description box. And also do let me know that which topic you want to see next for the fast track revision via mind maps, so that I'll be bringing you